Hi everyone, this is once again another session whereby we'll be dealing with Python and most importantly visualization. So in this session, I'll just be taking you through what visualization is, how you can leverage it, and how you can use it to tell stories with your data. The first thing I'll do is share my screen. And I've dubbed the topic storytelling with charts. My screen is way above my camera, so if you see me looking up, that might be the reason. So let's get started. How do you tell stories with charts? What can you do with charts? How can you go ahead and tell people this is an interpretation of the data that I have? We talked about cleaning your data and preparing it, but now you want people to also understand what your data says. You want them to know what everything around your data is all about. We'll be dealing with a data set on birds data from Minnesota, and it'll be interesting. You learn a bit about birds, bird sizes, and if you have domain knowledge on birds, that's even a better idea. But then let's get started. How exactly can we tell stories with charts? So we have some ways in which you can tell stories with charts. The first one being showing trends. So you want to show people this is what has been happening over. This is what is currently happening in different categories. So let's say ducks are small, falcons are a bit bigger, ducks can fly, ducks can't fly, can fly, chicken can fly, and so on. So giving them all these trends with your data. Then you can also show trends over time. We did this yesterday when we covered data preparation, whereby you can show people how data is moving over time, how your sales are going over time. And then you can also compare values, comparing probably ducks and falcons, comparing ostriches and chickens, comparing all of them. And lastly, not lastly, second last, showing the relationship between probably ostrich and chickens are flightless. That's one relationship you can show. Lastly, showing parts of a whole. So for example, in the whole bird ecosystem, ostrich make like 5% or 2%. That's something else you can show. But then you might be wondering, okay, this is things I can show with data, but how do I know which charts to use and where to use them? The first one is line charts to analyze trends per time. So drawing a line chart that tells you in January, the cryptocurrency was high and it's been dipping over that period of time. So you can be able to see, okay, it was green and then now it's red. Seeing the difference over time. That's line charts. Next one is comparing values. How do you compare between chicken and ostriches? So you can use things like bar charts, column charts, scatter plots, or pie charts. Bar and pie charts are kind of similar because they'll show you like the difference between two different parts. So that's also another thing. And then the other thing is how do you show how different parts relate to the whole? So for example, chickens, what percentage do chickens make of all the birds visualized? And there we'll go with a pie chart. Next one is showing distribution. How is data distributed over a period of time? So let's say the height. How do you know the height or length of different birds? How are they distributed? With this, you can use either a scatter plot or a bar chart. And then showing trends, as I mentioned, we have trends over time, but then we also have these trends to just understand what's currently happening. That will use a line and a column chart. And lastly, showing relationship between values. So how do you know how chicken and ostrich are related? Use things like line plots, scatter plots, and bubble plots. So the next part we'll do is meaningful visualizations. But of course, before you even know what meaningful visualizations are, we first have to dive into the code. So we'll go back to Visual Studio Code. This time we also create a new, we'll come here and create a new, okay, I feel like I'll be looking above a lot, so that might be distractive. Let me have my video off. So we have, we'll come here and create a new file. So the other day we did data preparation. Today we're doing data visualization. So I'll call my file dataviz.ipynd. That's it. So of course, the first thing is getting our libraries. And instead of you going over again and redoing the whole libraries that you need and stuff, you can just copy paste that from our previous file. So you come to the libraries we imported here, just copy them and paste a new library, because of course we'll be using all the libraries that we used yesterday with an addition of a new one, that is import seaborn as. Importing seaborn as SNS. This is another visualization library, and if you press Control Enter, you may not even have seaborn installed. So you can come down here and do pip install. All seaborn. Then enter, and it will install seaborn for you. So that's it with our terminal. I don't think we'll be using it again in the whole illustration. And then the second part, of course, is getting our data. So I'm finding it hard to type on the PC, on this PC, but I'll try my best. So we can do importing our data. So that will be pd.read_csv, and then determining, okay, which data set are we using. I'll share the data set as I share the video. The data set is also a part of the curriculum. So you will use the GitHub data set, have it downloaded, Control V, the GitHub link, and then let's see how our data frame looks like and what data it contains. So first is the name, so the name of the birds, the common name that we use. Second, the scientific name, and then the category under which they form. And then this is a bit of biology, so the order, the family, and the genus. I am not very good at biology, so I may not know like what each of this means, but it's just the placements of like human beings and Homo sapiens and so on, something similar like that. Then conservation status, this I'll explain a bit more in depth as we continue, but it just shows like if this bird is extinct, it requires very high conservation or not. And then the length of the birds. So birds have different lengths, same as human beings, but then they have like a minimum and maximum length of like the different birds. So probably something like a black-billed whistling duck, it might go all the way to 56, but it can also stagnate at 47. And then the minimum body mass, so same as human beings. So there's some people who have kgs of about 50, and there are those who go to all the way to 100 kgs or more. So same, minimum body mass, maximum body mass. Then the wingspan, so when you expand the wings, how big or how small does it get? So the other thing you can do is go ahead and try to display now the quantities. So displaying quantities is just using a basic line plot. So let's do probably the wingspan. So maximum wingspan, and then the plotting sort of plot, and show plot plt dot show, and let's comes. So you can see our data, yes, is showing very well, but then you can see there's a problem. There are birds that are extremely, like they have an extremely lengthy wingspan, and there are those most of them lie in the same the same number. So these are things called outliers. Outliers are when you see like someone is performing way outside like the average or the mean. So this bad is definitely an outlier. So we'll need to figure out, okay, how do we now go about fixing it? Because that's actually a very, very long line. The first thing we can do is first create a label to identify which bad the outlier is. So I won't write the code one by one because it will take a minute. I'll just paste code that I had already written that's already on the syllabus and the curriculum and explain to you. So this is the title, the maximum wingspan. And then we have the labels. So we have the label of the table. Oh no, we have the maximum wingspan, and then the Y label, then the X label, then X. The X label is now like for each you're labeling the birds, the name of the birds, and then X6 is now like how do you place the names? So you can see they're placed at a 45-degree angle, and then of course now identifying which side is the x-axis. The x-axis is this one, the x-axis is this one, and then the y-axis is this one. So now going ahead and plotting it, and you can see there are so many birds. Let's actually just figure out how many birds are there. So I'll do df.nunique. How many birds do we have in the whole category? There are about 443. So definitely you can't see anything. You have 443 birds. So that means we have to do something different. And something different in our case will be using a scatter plot. Again, writing the code will take a bit of a lengthy time. So I'll just it and then explain. But if you're writing your code, please ensure you write it all down. So here it is. So the first thing is, again, retain the titles the way they are, and then the tick parameters. The tick parameters, as I mentioned, are now like the different items. So for the wingspan in centimeters, the y-axis is just labeling numbers, but then for the x-axis, it would have given us the same thing as up there. But we want it to just give us a specific number of specific labels, the ones that are outliers. So we'll go ahead and do a for loop. As you did, we didn't cover for loops in class, but I'm sure you covered it in lesson between lesson 2 and 5 of the introduction to Python. So that's something you go back and review and figure it out. And then, but for loops, it's just printing items in a range. So for I, that's anything. So for I, in this case, stands for bird. So the names of the birds or the rows in range, so in the range of the length of the data frame. So X will be the name, that's I, and then Y will be the maximum wingspan. So that's the data frame name, that will be X, then the data frame of the wingspan will be Y. And then you print all the I's there, and then plot. BO stands for the bubbles. So plotting the chart, the small round blue dots using BO. And then from there, if like the maximum, the wingspan is greater than 500, give it the name size. That's generally it. So we have two wingspans that are greater than 500, which is the bald eagle and the prairie falcon. So of course, we would love to have our data more uniform. So you can do away with these birds. You can stay with them, but you can also do away with them. The best thing in this case would be filtering from outliers to ensure people can actually see the range better. Because with the bald eagle and the prairie falcon, you can barely tell the length of the others. So what we'll do, again, I'll copy the code instead of typing it out because of time. Paste it here, and then again, so we are now filtering the outliers to make the data very visible. So again, using the same thing for the values in for I in the range of like the whole data frame. If the data frame name is not bald eagle or prairie falcon, you can print. But if it's those two, please do not print them out, and then show what the graph will look like. That's it about making your visualization better understandable, and also ensuring that you can actually be able to see the range and the distribution and everything as the quantity as it should be seen. So from there, the next thing we can do is ask ourselves like different questions. You've been able to like see how the wing span of the different birds are, the maximum wingspan. So we can ask questions like, okay, so how many categories of birds are there? And then in each category, how many birds are there? And then of course, things like how many birds are extinct, rare, common, that's the conservation status. And then lastly, how many various genus and orders are there? So this is just like the categorization of everything. So one thing we can do is do a bar graph to like show us the different quantity of the different items. So for example, we can do the category. So we can do the category of the different birds. So as we can see up here, category shows like where they belong. And if we do a unique down here, you can see the categories are 60. So we want to plot them and see the distribution, how they're distributed and so on. So we'll go ahead and do another graph, a very simple graph. So let me type this out, df.plot. X-axis will be category. And then what type of graph are we doing? We're doing a bar graph to be able to see how they're distributed. And then the other thing is, do we want it stacked on top of each other, or do we want it just to show the different birds without anything else? So we want it stacked, which is true. And then the last thing is the title. Because graphs are meaningless. If someone sees a graph without a title, most of the time they're meaningless. So we want to know the categories of the different birds. And again, the category is 60. So the likelihood of us being able to tell the categories they belong is very hard, especially since you can't read any of the names. So we want to make them a bit polished. We want to see the data a bit polished, see it. But the main thing we want to do is understand like how the categories are distributed. That will mean we use value counts. So again, I won't be able to write the entirety of the code, but I'll paste it from the curriculum and show you what it means. The first thing is we want to do the value counts of the category. So figuring out how many categories do we have. Second is telling the figure, this is the figure that we want, and then plot the graph. And then you can see it has bar, but then it has H at the end. So this is defining it that it should be vertical. And you see it's actually better. You can see the different categories, how they're distributed. And of course, ducks are the most birds found in the Minnesota area. This might be because it's in the ocean. near the leg, of course, so that might be a reason. Okay, and then not to continue more on the quantities, I believe you can explore and understand, okay, you've already understood how the quantity are, how you can display bar graph vertically, and then you can go ahead and ask yourself different questions. So how does it compare to probably the mean length? So what is like the minimum length of the birds in a category or something of that sort? So for example, this is the last example I'm using in showing quantities. So if you paste this code and it gives you now like you're plotting a graph that shows maximum length and then minimum length. So you can see the maximum and minimum length of the different birds. So for example, you can see cardinal eyelids, they're not tall, but things like herons, pelicans, they're actually longer compared to the other birds. Cranes, duck, geese, waterfowl, in that category, they're longer than the other parts. So the next part of this that will show is distribution. So distribution is basically just showing you how the different birds are in a region. So for example, we can plot a scatter graph, df.plot into and is equal to, and then tell them which scatter do we want. So you want it to show like the x-axis to show us the maximum length or max length, and then the y-axis to show us the order. And then lastly, our figure size, we want it to be figure size, we want it to be about 15 by 10. And then go ahead, control. Let's see what comes of it. So it's telling us there's some errors. So there's some things that we've not done, of course. And one of the things is one of the things is our maximum length. We've not defined it well. So control enter. That's it. You can see how they're distributed. So it's the same as how you can see it here, but then it just shows you most of them are like, it shows you, okay, so of course the maximum length is about this side, the minimum is this other side, but then how many birds are in that category. So now you can be able to see them. So most of the passeriforms are here, falcons, very well distributed, charadiforms, there's some here, a lot here, and then a few at the end. And then anseriforms, there's some here, majority are in this side, and then of course there's some who have higher length. But then the majority are between 20, let's say this is about 40 to about 75 is where the majority lie. So that's the first way you can show distribution. The other way is using histograms. Histograms show distribution for numeric data. And for example, we have max body mass as numeric data. So max body mass, then you want to plot it, dot plot. And the kind of plot we want is a kind histogram. So we'll type hist, and then the other thing we define is the bins. So how many do you want stacked together in like a distribution by dividing like the array of data into with the same bins. So we're going to divide it with 10. And then of course size. So on the last one would be fig size, fig 2. So you can do 15 by 15. let's see how it looks. Oh, interesting. What is the error this time? Oh, technically, it's given me the answer. So here you can see there's a lot concentrated here, but then you can't, it's the same thing as what we experienced earlier. You can't be able to tell like the others because all of them are scattered at above 400, 350. So the same thing we'll do as we did earlier is filtering our data. So we'll go ahead and probably add the bins. So let's do the same code and try to add more bins. Control C and see if it will solve the issue. So we can add upwards of 50 bins. Let's see. Let's. It helps, but still not much of a big difference. If we go, let's go 20, you will see there's a difference. Yeah, still not much of a difference. So that means we have to go again and filter our data. So in this case, we can filter to show birds whose body mass are just below 60. So instead of showing body mass of everything, we just focus on those below 60. As you can see, majority lie below 60, but then there's a high number of birds that lie above 60, but with a big range of like 300 more than 60. So let's filter, but then use 60. So we'll do again. This is why learning Python was very important. You can be able to now do all these operations. So you can filter the data frame for body mass that's above 1 and below 60, and using the AND condition, and then doing the data the same way again. And you can see the difference. You can now tell the distribution, but then the distribution is not as smooth as you would want. So we want to make the distribution a bit, how can I say it, a bit smoother. So using things like line graphs and everything. So we can use, that's where Seaborn comes in. So you already import Seaborn, and we can use something called density plots. So we have a plot called KDE plot. So let's see how it looks. As you can KDE plot, and you want to see filtered, sorry, add df, and we only want to see the minimum width. Oh, sorry, I'm supposed to. And then we want to see how the plot looks like. Plot show. Let's see how it looks like. And you can see it's a bit smoother. Yes, it has the same, it looks the same as, no, this is different. So we can probably also do something with mass body index, but you can see how it looks. So you can be able to see how the birds are distributed. So majority lie between 20 and 30. So what if we do the same with max body mass? So to see if it actually represents what is shown. Oops, now then, max body mass, and then let's see how it looks. Will it look the same as above? Does it look the same? Of course, yes, it does. So that's also something you can be able to see. The plots are, of course, a bit smoother, and you can be able to tell a lot of what's going on. And then you can also add, like, you can also make your plots better. So add things like we're doing mass body index. So you can add things like, okay, that's what we're filtering. So what else can we do? So add things like hue. So our data, let's see, our data, let me not erase. So our data to the filtered data frame, and then the x-axis will be represented by mass, maximum body mass, and then the u will be something like the order. So how different maximum body masses relate from the order. But then you see, yes, you can see, but you can see the difference, right? But then we also want to make it a bit better. But then at least for now, you can see like how the different orders and families are doing. And then you can continue and add more parameters here, add more fields, like specifying whether you want them to be filled or not, whether you want the color palette, how do you want it to look, and then the alpha, which shows like my alpha shows the opacity. So for that code, I'll just paste it here, and we can see control enter, and you can see you can clearly tell the difference, like how different families are performing. Show like, okay, this I think it's the charity forms. They have a very high body mass index. And then that's it about showing you things like the quantities. So there are two other ways you can show data. The first, you can visualize data. The first one is visualizing the relationships. So there's the pair plot in SIPON. So if we do SIPON pair plot and then the whole data frame, let's see how amazing the visualization will look. You'll literally be able to tell how all of the data relates. So either with scatter plots or with bar graphs. It will show you, for example, let me go down here, so you can see, so the maximum wingspan and the length, this is how they relate. The maximum wingspan and the maximum wingspan, of course, they're the same thing. So it will just do a histogram showing you how they relate. Same to the others, so minimum wingspan and maximum wingspan, how they relate and so on. So being able to see how the different data sets, data columns reflect. The other thing you can do is a correlation matrix. So if I do df.cor, it will give me a correlation matrix. But then it won't show, I'm not sure what's happening. So it won't show me like the visualization, but it will show me outputs are collapsed. This is interesting. So if I do this, it won't show me the graphs. But if I do something like sns.heatmap and then have df.core inside, let's see what it will give me. I have no idea why the outputs are. Oh, this is what it means. So with a heat map, you can be able to see the colors, how the different items correlate. So they can either be highly correlated or very low correlation. And then, so you can see something like maximum wingspan and minimum wingspan are very highly correlated. It's, of course, if you are a family of like small wingspans, that means minimum and maximum are very closely related. Same to things like the minimum and maximum. So same to other things like, for example, the maximum body mass, the maximum body mass, the maximum body mass and the minimum body mass. See, they're also related. The thing that you'll be interpreting is, are they highly correlated or negatively or positively correlated? And then, so as it had refused to show us, so df.core, let's see what it will give. It will just give us any numbers without really showing us how it looks. And the last one is visualizing categories. Visualizing proportion of a whole. So because I have to cover one last part, I won't write the code down, but then I'll just copy paste it and you can see how they correlate. So this is interesting. The title, plot legend, and then remove this part. So, and then and add labels to this. So labels is equals to labels. Look, can I see? So the first thing is grouping the data, the data by conservation status. So grouping the data by conservation status will give us, let's see, copying this, it will give us a table that shows like how many birds are in different categories. So like the names, so for critically endangered, there's only one bird. For extinct, endangered, there's two. For extinct, there's one, and so on. But then there are vulnerable, which are 10. Then the most is like those that have very least concern. Of course, the numbers are the same across. Once we do that, then explaining the labels. So probably you want people to know what exactly they're seeing, and then now plotting the pie chart. So by plotting the pie chart, you can see things like the least concern are very many, and then the critical, endangered, and the extinct, since they're only just one, can barely see them. And then the other like near threatened, the 27, so you can be able to see them. Same to vulnerable. So that's how you plot a pie chart, showing like this is how the data is related to the other. So I think that covers about storytelling with data. But then the other main thing I should talk about is how do you then create meaningful visualizations. So the first thing is a quote from Ronald Coase. So you can see this in your curriculum, and it says, if you torture the data long enough, it will confess to anything. So you can use data to tell you a lot of things. But then there are things that you should really do. The first thing is create charts that actually depict what is right. So for example, this chart, it shows how violent crime has grown, but then you can see it's showing in reverse. So you used to the graph going from left to right, but then it's showing the graph going from right to left. And someone can say, yeah, of course, the violent crime has increased, but then in real sense, it hasn't. And then the other thing is color and style in your designs. So there are three main things you should note in this. The first one is make sure your designs and visualizations are accessible first, and then go through like the different meanings of color and color theory. For example, red is a warning color, and green is more of like a success kind of color. So when you're depicting like the rise and fall of crypto, we use green and crypto is falling. You're lying to people because at the end of the day, green shows high, then the green is falling. You're like, okay. And then the last thing is ensure your charts are readable. Then the other thing is I want you to explore more on data visualization, tell more stories with data, and you can do this through a framework called D3JS, whereby you can add animations to data. And then the other thing is doing 3D design of data. So what I'll call for you is to continue the curriculum. There are 4 lessons in this that I crammed into one video. That means there are things that I probably skipped, and also there are things that you might need further readings to understand. So ensure you go back, go through the video, understand what's happening, and then go through the curriculum, aka.ms/DS for beginners. So thank you so much for joining me again. I'm Bethany Jepchumba, and it was amazing doing this session. Till next time. Also, I'll do a blog to recap everything that we've covered here. Again, till next time, thank you so much.